Okay, 14.4.16c. All right, so we're looking at C. Where's my mouse? There it is. Oh, this is going to be difficult. All right, so here's C. I think what I'll do is I'll make this bigger. How about that? And make it blue. This should be more visible. All right, so let H in G be a normal subgroup, and suppose X1 is in G1H1 and X2 is in G2H2. Prove that X1, X2 is in G1, G2H. I'm sorry, I said G2H2, which is not true. X1 is in G1H and X2 is in G2H. Prove that X1, X2 is in G1, G2H, given that H is a normal subgroup. All right, so let's do a picture. Okay. All right. So the picture is down here. I'm going to put on my cursor attention because I can't see anything that's going on here. And it should pop up red in a moment. Why is it doing that? Well, that's all right. I can still see it. All right, so here's my G. Oops. Here's my G. And G divides up into cosets. I made them slices this time. I'm not going to do the raisins. All right, so X is in G1H and X2 is in G2H. Now, it doesn't say necessarily they're in different cosets, but so they could be in the same or in different. But anyway, this one is G1H. And then this one is G2H. Okay. And let's see. Then then X1 is here. And X2 is here. All right, now there's something else we know. Where is G1 and where is G2? You guys still there?
Yes.
Yes.
Where is G1 and where is G2?
Well, G1, I don't know. Honestly,
They're in the same
I don't
coset.
know.
G1's in the G1H, G2's in the G2H.
That's right. G1 has to be in G1H because H includes the identity. So G1 identity is included in G1H. So G1 is here.
Okay.
And G2 is here. All right, so we have this situation, and then X1, X2 is somewhere. So we don't know where it is. It could be anywhere. So let's just put X1, X2 over here. Okay. Now what we want to do is show that X1, X2 is in G1, G2H. Okay, so where must G1, G2 be? If this is true, where must G1, G2 be?
The same coset as X1, X2?
That's right. If X1, X2 is in G1, G2H, they have to be in the same coset, right? Because in fact, let's see. Because in fact, you could also write G1, G2, X1, if X1, X2, this means that X1, X2 is equal to G1, G2 times some particular H. Now, if I brought that H over to the other side and took an inverse, that would mean G1, G2 is in X1, X2 H. So in fact, these must be in the same coset. I'm going to put that in red because that's what we want to prove. So really that's what we want to prove. We want to prove G1, G2 is in the same coset as X1, X2. Now, I don't know what the hint says, but let's just go off that in intuition. So we want to prove right? Now, there's a bunch of ways to do that because I think we had several theorems that were equivalent. There's several conditions that were equivalent when things were in the same coset. I don't remember exactly where that was. There's a whole list of things that were equivalent, right, when things are in the same coset. Must be back previous section. Or is it the section before? Anybody remember where that is?
For which one?
Yeah, if you want two things to be in the same coset, all of these are equivalent. You see what I mean here? You have G2 is in G1H and G1 is also in G2H. So all of these are equivalent. So in our case here, we want to show two things are in the same coset. So which way do you want to prove? Take your pick.
I'm really not seeing the connection somehow between this. I don't know why, but I'm not quite seeing but it says X1 times X2 or X1 composition X2, whatever
Mommy or Daddy,
it might be.
20.
And I'm not really sure. I don't know. I'm not sure what to do here.
All right. Well, all right. So then we need to backtrack, I think. I mean, there's only one group operation. So composition or times, you can call either one. That's fine. You typically call group operation times. It's okay. So, I mean, do you get this picture?
Yes.
All right. Do you see why all we need to do is prove this?
I don't think I really quite get why that is what we're trying to prove.
All right, well, let's backtrack a little bit then. So let me do an alternative. I'll put it in green because maybe we'll do that instead. Okay. What does this actually mean? What does it mean that X1, X2 is in G1, G2H? What does that mean?
That X1 times X2,
If you take that G1 and G2 and you multiply it by some H, it's going to equal X1 times X2.
Okay, yes. So you say if you take G1 times G2 times some H, you don't know which H, but some H. There is some little h. There's some little h in this subgroup. Some little h in this subgroup that when I take G1 times G2 times little h, that gives me X1, X2.
yes, I get that.
All right, so I can, the best way to say that is alternately, I'll say alternately to prove. All right, so maybe that first one doesn't work so well. Let's try this one instead. So here we said there is some little h. So the best way to say that mathematically is to say there exists little h in big H, such that what? Just to make sure you got this, such that what?
G1, G2 times little h is equal to X1, X2.
Okay, very good. All right, so that's what we want to prove. So this is to prove. So you can't use this in the proof. This is what you want to prove. Okay. So we're given, so let's downwrite the givens again. We're given that X1 is in G1H, and X2 is in G2H, and H is normal.
I just could not find a way to combine the two.
All right, now, All right, so let's look at this. What does this mean?
That X is G times some little h.
All right, well, we've already used little h.
Well, I mean, I guess H sub 1
Okay, very good.
or something.
So that means that x1 equals g1 h1.
Yes.
Okay. And,
X2 equals G1 H2.
well, not quite.
Oh.
G2 h2.
Oh, I'm sorry, G2 H2.
Okay. All right. All right. So this is from the definition of coset, right?
Yes.
Okay. All right now, what we want to show, what we're trying to show this, right?
Yes.
So what do you want to do with this, with these two facts together?
I mean, I guess you want to multiply them.
Sure. Let's do that. Okay. So that means x1, x2 equals g1 h1, g2 h2.
And that's exactly where I got stuck.
Okay, good. So you got this far. Okay.
Yeah.
Now we've used the fact. We've used this. We haven't used this.
Mm-hmm.
All right. So what do you want to use from there?
I guess. Oh, okay. Well,
Go back and
So
see what we can
that
use.
means that we could rearrange something because G1H, we could rearrange them is what I'm saying. That means that left and right cosets are equal.
Okay. All right. So left and right cosets are equal.
So we could put the G on either side. I'm just not sure how that's helping me.
Okay. All right. So let's see. So H is normal.
Mm-hmm.
Now, let's see. Where do you want the H's to go?
Um,
On the right.
On the right.
okay.
Okay. So it's like American style driving, not British style. So,
Okay.
all right. Now this guy's in the wrong lane.
Yeah.
So he's got to change lanes. With who?
Somehow he's got to move into that G2 spot.
Well, he's got to hop over G2. He's got to hop to the other side of G2. Now you said H is normal means that the two cosets are equal. So which cosets are equal? Do we want which in particular? Which cosets are we going to make equal?
So GH1 and H1G1 would be the same.
All right. So this is true, but you said it wrong.
Oh, okay. Right. Right.
H1G2 is the same as G2H1.
No, there's no H1 here.
It's just yeah, because it's the entire
There's
set
no
of
H1. It's the entire set. So be careful. Cosets. Normal is a statement about the cosets, not about individual elements.
And I think I was a little unsure here. Does that mean that GH and HG, same H, are equivalent?
No.
Okay, so
And you have some examples.
okay, yes, you're right.
Okay.
So
We have some examples that show that. So that's not true.
Okay. But okay, so that puts a little bit of a monkey wrench in some of my problems so far.
All right,
Even
now, what this is doing is that this is moving H from the right-hand side of G1 to the left-hand side of G1.
So what you're saying is that even though the individual components, GH and HG, are not the same, when you finish it all and multiply all or composite all of the elements of H with G1, they will ultimately be the same.
Yes, that's exactly right. Here you're going to
Okay.
get, if you list the H's one by one,
Yeah.
then this will give you a set.
Okay.
Now here, if you list the H's one by one, this will give you a set.
But not necessarily the same H.
Not in the same order. Not in the same order. Very important point.
Yes.
So the
okay.
sets are
That's
the same.
very important. Yeah.
So let me just say that. So I'll just say that this element sets are the same, but not element by element.
Okay. Yeah, I think that changes some of the things I've already done.
All right. But what that does mean, but what I'm getting at here is that here we've got a H on the right-hand side.
Mm-hmm.
So what does that mean? So for instance, this would imply, we'll go back to green. This implies, what does this imply? This implies G1H1 equals what?
H2 or some H prime
Let's
or
call
some.
H1 prime. Very good. Let's call H1 prime. Just to, H1 prime times what?
Times G1.
Times G1. Very good. For some H1 prime. Okay, and this is the definition of set equality. All right. Now, is that going to help you?
I assuming possibly.
Yeah, possibly. Now, let's look a step ahead. Here I have G1H. Here I have G1H. I can change this G1H into H1 prime G1.
Sure.
All right. So that would, I could do substitution, and I could get x1, x2 equals H1 prime G1, G2, H2. And this is just substitution.
So I guess G1, G2 is some other G.
Well, we don't want some other G. We want G1, G2, remember? We want G1, G2.
Okay.
We don't want some other G.
Okay. Okay.
But there's a problem here. Here we want G1, G2H. But here we don't have G1, G2H.
Right.
Here we want a pizza. Here we have a sandwich. With G1, G2 is in the middle of the sandwich. But you don't want a sandwich, you want a pizza. Or an open-faced sandwich.
So do we want to multiply left? Oh, no, I don't know. Honestly, I'm not sure.
All right, well, this was good. I mean, look at what you did. This is a very good thing. You moved this H to somewhere else.
Okay.
But you moved it to the wrong place.
Why did you let me do that?
Well, you're a teacher. Why are you asking me that question?
Our strategies have turned against us.
Okay. Okay.
You don't want to move it there.
Yeah, this is not helpful.
Well, you do want to move it. You just moved it the wrong way. Can you move it the other way?
I suppose so.
Then what do you, how are you going to move
Well,
it?
if we let G2H2 equal
All right, don't say H2.
something,
All right, so you use G1.
maybe we should use G2.
Let's try G2. I mean, what else? What can you lose?
Not a darn thing.
All right, so let's see. So I'm just going to backtrack. I mean, if you're doing it, whoops, sorry. Okay, and there's a 2. There's a 2. All right, so what does that give me?
So change the 1s to 2s as far as the next step.
All right, so we can do G2, H2. Sorry, it's not. Okay.
No, it's fine.
Okay. Well, here, let me erase it because it's going to get too junky. Let's see. G2, H2 equals H2 prime G2. All right, so what does that give me? So this is not right. I have to change this. What does that give me
Okay,
then?
so now we have G1, H1
You have G1, H1.
and H2 prime G2.
Prime G2. Uh-oh. So now you have a calzone.
Yeah.
You want a pizza, you have a calzone. You put it inside. So it's still not right.
Well, that's not helpful.
Is there anything else you can do? Well, look at what you did. You took the G2 and the H2, and you flipped them around. But that's not what you want to do.
I feel like I'm chasing a rabbit.
Well, you've shown that you can move the H1. You can move the H1 over here. You can move the H2 over here, but you want to move the H1 over here. You want to move this H1 to the other side of G2. So how are you going to do that?
I have no idea. Somehow G2 is going to have to be in terms of H1, and I don't.
Well, H1, really, there's no difference between H1 and H2. They're arbitrary elements of H, right?
Yes, but they're still different elements.
They're different elements, that's true.
Possibly.
All right, does anybody see a way forward?
Well, if you multiplied H1 to G2, you would still get an element of the same set as G2, H2.
All right, so if you take H1, G2, so you're saying take H1, G2.
Right.
Okay, let's do that. H1, G2. So you say it's the same set as G2, H2?
Right.
So how are we going to denote that? Well, I want an equality here.
Well, I mean, following the pattern from before, it would equal G2, H1 prime.
Well, I don't want to use H1 prime. Let's call it something else. No, we can call it H1 prime, sure. H1 prime is fine. Okay, that's all right. Yeah, so that's following the pattern from before. So, what a dumb idea. What are you going to do with that?
Substitute.
All right, so Christy, what do I get?
Well, then you would get G1,
Yes.
G2.
Oops, why is it still erasing? Uh-oh, what I said is on tape. I'm going to get sued. G1. Right, sorry. G1.
What in the world?